Hello, my dear friends. Today we are going to study spectrophotometry. It is a lab technique used to measure the absorbance of a light of particular wavelength by a substance. This technique, spectrophotometry, works on the principle of the Beer-Lambert's law. What does Beer-Lambert's law says? It says that absorbance of any compound is directly proportional to the C concentration of the compound. Here we have the Beer-Lambert law equation, and these are the things which we depicted here, and their names: A absorbance, E molar absorbability, L is length of cuvette, which is always 1 centimeter, C is the concentration. And now we have the working principle, or we say the components of the spectrophotometer. Here is the light source. It produces the light of specific wavelength. Then this light is passed through the monocoulometer, which collects this light produced by light source together, and it focuses it on the monochromator. Monochromator is usually a prism which splits this light into a spectrum of 7 colors: violet, indigo, blue, green, yellow, and orange. After that, this light is passed through the slit or wavelength selector. The slit or wavelength selector selects a particular wavelength. Then this particular wavelength of light is allowed to pass through the cuvette containing the sample solution. Okay, after that, this sample solution, the light which passes through the sample solution, is detected. Some light is absorbed by the sample solution, and some is transmitted. The light transmitted is detected on this detector. This detector detects the light, and after that, the light, this detector is usually a photodiode. It converts it into the electrical signal. Then this electrical signal displays the amount of concentration or absorbance or transmittance on the screen. Now, this is the this is the spectrophotometer. Now we talk about the applications of this spectrophotometer. It is used in pharmaceutical industry to check drug concentration, to check drug stability. It is used to measure the concentration of DNA and RNA. It is also used to check water pollution. It is also used in medical tests like liver functioning test, kidney functioning test. It's used in food industry to check for adulteration of the food. It's used in also medical to check the glucose and enzyme in the blood. These are its applications. Now coming together with the types of spectrophotometry, we have the UV spectrophotometry, visible spectrophotometry, infrared spectrophotometry. UV spectrophotometry is used to study the nucleic acid and drugs. Visible spectrophotometry is used to study the color compounds and metal ions. And here we use the visible light of 400 to 700 nanometer. Here we use the wavelength of 200 to 400 nanometer. And in infrared we use the wavelength greater than 700 nanometer. Here we study the functional groups and the molecular vibration. I hope you understood the topic. Thank you so much for watching. Till then, goodbye. Take care.